Okay, so this week for our last week of new material for remote learning, we are going to be working on 3D figures and finding information about them, specifically surface area and volume. So quick refresher, what is surface area? It is the total area that the 3D shape takes up. So if you think about, for instance, like a dresser, it's the total area it takes up, not how much we can fill up in that, but how much space it takes up in our 3D world. And so we do this by finding the area of all the faces, which are the sides of the shape, and then we just add them all together. So these are some common formulas. So with this week, like last week, on workbook page 160, all these formulas are listed. The volume formulas are going to be listed there as well. And so this will just help us, you don't have to memorize these. They'll just help you with your assignments. I've also uploaded the page onto Schoology if you do not have your workbook or threw it away, okay? One thing, R stands for radius, H stands for height. So what this S stands for in a cone, I'm going to draw a little cone here really quick. So if you look at a cone, here's R, there's the radius. What the S stands for is, if I shade this side in right here, it's this side length right here. Okay, so that is what the S is. So sometimes you might have to use some right triangle Pythagorean theorem, right? If you have the H and you don't have this, in order to find that side length, okay? So I'm just going to go over some examples to kind of give you an idea of what this looks like. So for a sphere, the surface area formula is 4 pi r squared. So the nice thing is the radius is given to us. So we just do 4 pi 1 squared. And then in your Schoology assignments, you are rounding everything to the nearest hundredth. So we get 12.566. So remember, when we round to the nearest hundredth, we look at the one next to it. Since it's 5 or above, we round it up, and it's 12.57 miles squared. So that was that one. So then here, surface area for a cylinder is 2 pi RH plus 2 pi r squared. So if you think about it, you should recognize pi r squared is the area of a circle. So again, if we're thinking about the faces, right? If you think about a cylinder, so one that is easy to think about is a soup can, right? There's a top and there's a bottom. Well, those are both shapes of the circle, or those are both circles. And to find the area of a circle, we do pi r squared, and we have two of them, right? One on the top, one on the bottom. Okay, so there's that. Then we have this side here, right? So you think about the wrapper on a cylinder that goes all the way around. That right there is this 2 pi RH, okay? So we're gonna plug it in. So 2 pi, the radius is 8, the height is 6, and then 2 pi 8 squared. So I am going to type this into my calculator all at once. So 2 pi 8 times 6 plus 2 pi times 64, 8 squared. So I get 703.716. So that rounds up to be 703.72 feet squared. And if you think about this one is significantly larger. So think about surface area. You are going to get some larger values. Well, what is 8 squared? That's 64. So if I'm doing 2 times 64, that's 128, then times pi, which is 3, right? These values are going to grow quickly, especially when things are being squared. So just a heads up, if you get large values, that is okay. All right, so here, these are both examples of prisms. So surface area for a prism is all the area faces added up. So if I look at my first one, it's a rectangular prism because the base is a rectangle. I see this small rectangle of 6 by 4, right? This is 6 yards, this is 4 yards. Well, to find the area of that, I do 6 times 4. But that's not the only spot where I have a 6 by 4 rectangle, right? I have one here. So since I have 2 of those, I'm going to multiply this by 2. Plus, Okay, well now I'm going to look at some of my other rectangles. Well, now I have a 9 by 4. I'm going to shade that one in. Well, that's in the front and there's one in the back. So I'm going to do 2 times 9 times 4. Plus, finally, on the bottom here I have this 9 by 6, right? Because that's 6. So 9, whoops, not 9 of them. We have 2 of them. 9 times 6. So again, like earlier, I am just going to type that into my calculator all at once. Right? If you use parentheses, your calculator will know order of operations. And I get 228 yards squared. So there's that surface area. So here, this one is a trapezoidal prism, right? Because it has one set of parallel sides and it has that one set of sides that are congruent. So it's actually an isosceles trapezoid. So to find the area of a trapezoid, this is on that workbook page 160. You do 1/2 times base 1 plus base 2 times the height. So this right here is the height of the trapezoid. And then the bases are 8 and 5. Well, if you think about it, I have this one in the front and this one in the back. So we're going to do 2 times 1/2, 8 plus 5 times the height of 4.8. Okay. Now that's not the only dimension that's 5. This one's 5. This one's 5. But this slanted side right here is also 5, right? Because it's a rectangle. So we have this top rectangle of a 14 by 8. I only have one of those. So then you got to think, well, what about the other faces? So I have 1, 2, 3 that are missing. So how I know this is if this is 5 and this is 14, we have this bottom one. Then we have this side is 5 and 14 and we have it 2 times. So in total, we have it 3 times. So then I'm just gonna type this in all at once into my calculator. Times 4.8 plus 14 times 8 plus 3 times 5 times 14. And then this one's gonna be a somewhat large one, 384.4 centimeters squared. So there's that surface area, okay? So our last example tells me a birthday gift is in the shape of 55 centimeters, 40 centimeters, and 5 centimeters high. So that is going to be a rectangular prism, right? So I have 55 centimeters, 40 centimeters, and it's only 5 centimeters high, okay? Look at that. Not the best, but you get the idea. So 55 centimeters, 5 centimeters, and 40 centimeters. So again, what is the minimum size of paper you need to wrap a gift? So if you think about this, when you're wrapping a gift, right, you're not filling up the box, you're just wrapping the box in paper. So you're gonna find the surface area to see how much space it takes up. So if I think about this 55 and 5, I have 2 of those. And then I have this 55 right here and 40. I have one on the top and one on the bottom. So again, I have 2. So if you notice the trend with rectangular prisms, and cubes are kind of the same, that they have 2 of each face. And then I have a 5 and a 40 and on this side and then on that side as well. So 5 times 40. So 255 times 5 plus 255 times 40 plus 2, 5 times 40. So I need, at minimum, something that will cover 5,350 centimeters squared, okay? So that is how you find the surface area of 3D shapes.